Hello, this is our regression data analysis project on marijuana. My name is Xander Wiersham.
I'm Graham Gonzalez.
And Maury Atlery.
I'm Hannah Pinkerton.
And I'm Kristen Knight.
So first, I'm going to talk a little bit about the background. So we decided on this topic because there has been a drastic shift in the narrative surrounding marijuana and cannabis use in our lifetimes. During the first part of our life in the 20th century, the war on drugs was the general narrative. However, that has shifted dramatically to this medical use with leagues such as the MLB, the NBA, and the NFL, reducing their consequences for failing drug tests, with it being used more as treatment rather than as a addiction. So we're going to focus on a couple of different factors from this specific set of data. We're going to try and determine the first use of age of marijuana from the first use of a cigarette, the age of the first use of a hallucinogen, and the number of days skipped work in the past 30 days. So the data that we're using is from the National Survey on Drug Use and Health. The principal investigators were the U.S. Department of Health and Human Services, Substance Abuse and Mental Health Survey Administration, and the Center for Behavioral Health Statistics and Quality. Our group analyzed and felt that the data was collected fairly and appropriately. We see no statistical rules being broken in the collection of this. So now I'm going to hand it over to Graham to talk about the methods.
Awesome. Thanks, Andrew. So after picking 16 variables, earlier on, we made a parsimonious model out of these 16 variables to try and see which ones of them had the most predictive power. Out of those, age of first cigarette, age of first use of hallucinogen, and days skipped work in the last 30 days had the most predictive power. And so that is how we ended up arriving to our original our final model of using these variables. So the data cleaning for this was pretty extensive. We knew that since this was real world data with over 4,000 columns and 55,000 observations, that this was going to be pretty tricky. First, we had to make a subset of the data, which is what we did, and only using those three predictor variables and the response variable. Getting rid of the NAs was pretty simple. We just used NA.omit after finding the subset. And then after that, further cleaning of the process due to practical significance, we decided to exclude any of the younger population under than 12, because this would not signify a normal household and could be an instance of abuse or something like that. In addition, we decided that 50 years or older were out of the range of data that we were trying to test, and we're not going to improve our model and would only hinder it. And then we excluded any responses that were greater than 20 days of days that were skipped in the last week. After cleaning the data, we were left with 3,804 observations, which is still a hefty number of observations. Looking into some of the outliers, we didn't have any outliers for marijuana use. We had a wide range of answers, but we considered those to be important and have, I guess, practical significance when looking at the predictability of it. After looking at age of first cigarette, we saw that there were 6 outliers that did not meet Cook's distance whenever we plotted them against first marijuana use. All of these had high points of leverage and were not useful to data. So most of them, actually all of them for cigarette, made no sense. And so we decided to exclude them from the data set, as well as age of first use of hallucinogens. There were 3 outliers that were found that were well outside of Cook's distance. And this was, I think, marijuana was used at 13, and hallucinogen was at 50, which was the cutoff of our age, and it just didn't make sense to include it. So after excluding these variables for these observations of these 3 variables, we were able to improve the correlation of each of these variables on age of first marijuana use, as well as days skipped work in the last 30 days. We decided to do that because like we said earlier, the average nationally, the average days skipped before being fired is 14 days. So there was no reason to use anything over 20. And so no outliers were found, but there were a few that were on the edge. In an attempt to meet the regression assumptions, we used multiple transformations to our regression model, including square root, log of x, log of y, square root of x, square root of y, all of these in different combinations to try and make a better model. We concluded that none of these made any difference on our plots or correlation or predictability. So we found that there wasn't any use for them. We analyzed the quartiles for each of these variables and found that the interquartile range for all of these variables that included drugs, or in this case nicotine, were between 12 and 16 years old, meaning that there was a very high, dense population that was recorded between the ages of 12 and 16. So we had a couple of curves on our QQ plots representing that as the data got further along, or as age progressed, there was a little bit, the residuals might have gotten higher or lower. But this is to be expected with real world data, since it wouldn't be perfectly normal. Most of our data plots were in fact skewed to the right as well. And to go over some more of the statistical importance of our variables is Kristen.
Thanks, Graham. So the first variable that we're going to look at is the response variable, and this is the age of first marijuana use. And the mean for this variable is 15.81, and the standard deviation is 2.59. And then you can see the box plot and the histogram that shows the distribution of this variable. The second variable we'll look at is the first predictor variable, and that's age of first cigarette. The mean for this variable is 15.38, and the standard deviation is 2.6. And again, you can see the box plot and the histogram that shows the distribution. And then we also have a plot that shows the relationship between the response variable and this predictor variable. The next variable is first use of hallucinogens. The mean is 18.61, and the standard deviation is 3.36. Again, you can see the histogram in the box plot for the distribution, and the plot showing the relationship with the response variable. And the last predictor variable is days skipped work in the past 30 days. And the mean is 0.24, and the standard deviation is 0.88. And again, you can see the histogram and the box plot that shows the distribution, and the plot that shows the relationship with the response variable. And next, I'll pass it off to Moria to discuss the results.
Thanks, Kristen. So for our final regression model, we had the marijuana age of first use is equal to 4.547 plus 0.322 times the age of first cigarette plus 0.34 times the age of first hallucinogen minus 0.051 times the number of days missed work in the last 30 days. And then we made a prediction with the age of first cigarette at 15, age of first hallucinogen at 17, and the days missed work in the last 30 days is 2. And that gave us a value of 15.046 with a confidence interval of 14.898 and 15.196. And the confidence intervals for each of the coefficients in the model were also relatively small, so it wasn't too wide a range, so there wasn't like too much variability in our model. The multiple R squared for our model was 0.3824, and the adjusted R squared is 0.3819, which means that given the number of variables we had, the model accounted for 38.19% of variation in the age of first marijuana use that was predicted. And the p-value of the model and all the coefficients other than the number of days missed work was relatively low, almost near 0. And the p-value of the workflow variable was 0.171. And as Graham said earlier, this is because of the data just not being as expected, and because it's real world data and it's outside of our control. And now Hannah will give our conclusions on our report.
Thanks, Mara. So for the conclusions, our model that we created resulted in an adjusted R squared of 38%. It included the three variables that we believe have the most predictive power. So those three variables include the age of first cigarette use, the age of first hallucinogen use, and days skipped work in the past 30 days. We found this to be the most efficient model using age of first marijuana use as our response variable. For the limitations, the size of this data set was extremely large, so that made it difficult for us to manage. It had a lot of missing values, so we had to rule out some of the missing data and some of the outliers that would have affected our results. Another limitation was the variation in the survey participant responses, so we had to carefully consider some of the underlying reasons why there was so much variation in the responses, and we believe that was due to the fact that some of the participants either didn't remember or they weren't comfortable answering some of the questions. So overall, this model helped us to predict age of first marijuana use among people who have used marijuana. As for future work, we believe that our model may be useful to do further research on the idea that marijuana is linked to nicotine addiction because we have age of first cigarette use as one of our predictor variables. Thank you.